Pluto resides in a distant region of our solar system called the Kuiper Belt. This vast, donut-shaped region is filled with icy bodies and remnants from the solar system's formation. It's a mysterious and largely unexplored area that holds many secrets about the early days of our cosmic neighborhood. This region lies beyond the orbit of Neptune, the eighth planet from the Sun. The Kuiper Belt extends from about 30 to 55 astronomical units, AU, from the Sun, with 1 AU being the distance from the Earth to the Sun. It's a frontier of our solar system, marking the boundary between the known and the unknown. Pluto, once considered our ninth planet, is now classified as a dwarf planet. This reclassification occurred in 2006 when the International Astronomical Union, IAU, introduced a new definition of what constitutes a planet. According to the IAU, a planet must orbit the Sun, be spherical in shape, and have cleared its orbit of other debris. Pluto meets the first two criteria, but not the third, leading to its reclassification. This reclassification sparked much debate and intrigue within the scientific community and beyond. Many people felt a sentimental attachment to Pluto as the ninth planet, and the decision was met with both support and opposition. The debate highlighted the dynamic and ever-evolving nature of scientific understanding and classification. Despite its demotion, Pluto remains a captivating celestial body with many stories to tell. Its surface is a complex and varied landscape, featuring mountains made of water ice, vast plains of frozen nitrogen, and even possible cryovolcanoes that spew icy materials instead of lava. These features make Pluto a fascinating subject of study for astronomers and planetary scientists. Pluto's story is one of scientific discovery and evolving understanding. Discovered in 1930 by Clyde Tombaugh, Pluto was the first object found in the Kuiper Belt and opened up a new realm of exploration in our solar system. Over the decades, our knowledge of Pluto has grown, especially with the New Horizons mission, which provided unprecedented close-up images and data in 2015. It reminds us that our knowledge of the universe is constantly expanding. Each new discovery, whether it's about Pluto or another celestial body, adds to our understanding of the cosmos and our place within it. The reclassification of Pluto is a testament to the fluid nature of scientific inquiry and the importance of remaining open to new information and perspectives. As we explore further into the cosmos, we can expect to encounter even more celestial wonders that challenge our preconceived notions and redefine our place in the vast expanse of space. The story of Pluto is just one chapter in the ongoing saga of space exploration, and it serves as a reminder of the endless possibilities that await us as we continue to push the boundaries of our knowledge and reach for the stars. Pluto stands out as a celestial oddball, a fascinating enigma in the vast expanse of our solar system. Despite being demoted from its status as the ninth planet, Pluto continues to captivate scientists and space enthusiasts alike with its unique and mysterious characteristics. This dwarf planet challenges our understanding of planetary bodies with its unusual characteristics. Its surface is a complex tapestry of ice and rock, with regions that are surprisingly smooth and others that are rugged and mountainous. One of the most intriguing aspects of Pluto is its highly elliptical orbit. Unlike the nearly circular orbits of the planets, Pluto's path around the Sun is stretched out, taking it closer to the Sun than Neptune at times, and then swinging far out into the depths of the Kuiper Belt. This peculiar orbit results in extreme temperature variations on Pluto's surface. When Pluto is closer to the Sun, its surface can warm up enough to cause some of its icy surface to sublimate, turning directly from solid to gas. Conversely, when Pluto is far from the Sun, temperatures plummet to frigid extremes, causing the atmosphere to freeze and fall back to the surface as snow. This cycle of warming and cooling creates a dynamic and ever-changing environment. This dramatic temperature swing contributes to the dynamic nature of Pluto's surface and its constantly changing features. The dwarf planet's surface is marked by vast plains, towering mountains, and deep valleys, all of which are sculpted by the interplay of its unique climate and geological activity. Adding to its mystique, Pluto has a thin atmosphere composed mainly of nitrogen, with traces of methane and carbon monoxide. This atmosphere is tenuous and changes with Pluto's distance from the Sun, creating layers of haze that can be seen in images taken by spacecraft. Pluto is also accompanied by a system of 5 known moons, the largest of which is Charon. Charon is so large relative to Pluto that the two bodies are often referred to as a double dwarf planet system. The gravitational interaction between Pluto and Charon creates fascinating dynamics, including tidal forces that affect both bodies. Our understanding of Pluto has been greatly enhanced by the New Horizons mission, which provided the first close-up images and data of this distant world. The mission revealed a world far more complex and diverse than previously imagined, sparking new questions and excitement about the outer reaches of our solar system. As we continue to explore and study Pluto, it remains a symbol of the mysteries that await us in the farthest corners of our solar system. Its unique characteristics remind us that there is still so much to learn and discover about the universe we inhabit. One of the most surprising facts about Pluto is its diminutive size. Despite being one of the most well-known objects in our solar system, Pluto is much smaller than many people realize. Often imagined as a large, planet-like body, Pluto is actually smaller than Earth's moon. This can be quite shocking to those who grew up thinking of Pluto as the 9th planet in our solar system. To put this into perspective, if Earth were the size of a basketball, the moon would be about the size of a tennis ball, and Pluto would be even smaller, closer to the size of a golf ball. This analogy helps us visualize just how tiny Pluto is compared to our own planet and its natural satellite. This size comparison highlights the significant difference in scale between these celestial objects. The vastness of space often makes it difficult to grasp the relative sizes of these bodies, but such comparisons bring it into clearer focus. It also emphasizes why Pluto's classification was reconsidered. In 2006, the International Astronomical Union, IAU, redefined the criteria for what constitutes a planet, leading to Pluto's reclassification as a dwarf planet. Size plays a crucial role in determining a celestial body's gravitational dominance, a key factor in the definition of a planet. A planet must be massive enough to clear its orbit of other debris, something Pluto, with its relatively small size and mass, cannot do. Pluto resides in the Kuiper Belt, a region of the solar system beyond Neptune filled with small, icy bodies. Its location and size are significant factors in its classification. Discovered in 1930 by Clyde Tombaugh, Pluto was initially celebrated as the 9th planet. However, as our understanding of the solar system evolved, so did our classification of celestial bodies. Pluto is not alone in its category. Other dwarf planets such as Eris, Haumea, and Makemake share similar characteristics, further justifying the need for a distinct classification. Understanding the true scale and classification of these celestial bodies helps us appreciate the complexity and diversity of our solar system. Each object, no matter its size, plays a unique role in the cosmic dance. So, while Pluto may be small, its story is a big part of our journey to understand the universe. Its reclassification reminds us that science is always evolving, and our quest for knowledge never ends. While Pluto and Earth's moon share the characteristic of being smaller than Earth, their similarities end there. These celestial bodies have vastly different compositions and features. Pluto's surface is covered in various ices, including nitrogen, methane, and water ice, giving it a distinct reddish hue. On the other hand, Earth's moon has a primarily rocky surface, scarred by impact craters and ancient lava flows. This stark contrast highlights the diversity of celestial bodies within our solar system. Pluto's discovery in 1930 by astronomer Clyde Tombaugh at the Lowell Observatory in Arizona was a landmark event in astronomical history. The search for Pluto was driven by the belief that a 9th planet, dubbed Planet X, was perturbing the orbits of Uranus and Neptune. Tombaugh's meticulous observations and analysis of photographic plates led him to identify a faint moving object that would later be recognized as Pluto. This discovery expanded the boundaries of our known solar system and ignited the imagination of people worldwide. In 2006, the International Astronomical Union, or IAU, made the historic decision to reclassify Pluto from a planet to a dwarf planet. This decision was not without controversy, sparking debates among astronomers and the public alike. The IAU's decision was based on a new definition of a planet, which Pluto did not meet. According to the IAU, a planet must orbit the Sun, have sufficient mass to assume hydrostatic equilibrium, a nearly round shape, and have cleared its orbital neighborhood of other objects. Pluto meets the first two criteria but not the third, leading to its reclassification. Despite its small size and distant location, Pluto possesses a thin but surprisingly complex atmosphere. This atmosphere is thought to be composed mainly of nitrogen, with traces of methane and carbon monoxide. What makes Pluto's atmosphere particularly intriguing is its variability. As Pluto moves along its elliptical orbit, its atmosphere undergoes significant changes. When Pluto is closer to the Sun, its surface ices sublimate, releasing gases into the atmosphere, making it denser. Conversely, as Pluto moves further from the Sun, its atmosphere partially freezes and falls back onto the surface. Pluto's largest moon, Charon, is a celestial body of significant size and influence. Discovered in 1978, Charon is so large relative to Pluto that the two bodies are often considered a binary system. They orbit a common center of mass located outside of Pluto, making their gravitational dance a unique phenomenon in our solar system. Charon's surface is thought to be primarily water ice, with hints of other materials like ammonia hydrate and tholins. From its distant location in the Kuiper Belt to its complex surface and intriguing atmosphere, Pluto continues to captivate astronomers and space enthusiasts alike. Though reclassified as a dwarf planet, Pluto's scientific value remains undiminished. Its unique characteristics provide valuable insights into the formation and evolution of our solar system. As we continue to explore the cosmos, Pluto serves as a reminder that there is still much to discover and understand about our universe.